Student, today we will learn the chapter Limits and Continuity and Differentiability. In the previous video, you have already learned the topic that what is the limits, and we have done some questions also, and in the continuity we also explain it. Now I am going to tell you the meaning of differentiability and relation with continuity and differentiability. Okay, what is the meaning of this I am going to be tell you now. You can see here is a curve. Okay, now take a 2 point here, x1, and here is x2, and this point is, and this point join it. This is a chord. Okay, x1, y1, x2, y2. Now slope of chord, since it is a curved line, so we can say y2 minus y1 upon x2 minus x1. This is slope of chord. Okay, now this slope of the chord, when this distance tends towards 0, means x2 minus x1, that is delta x. If delta x tends towards 0, what happened? Length of the chord will become near about 0 and it will be a tangent. So we can say now slope of the chord will be slope of tangent. So slope of chord becomes slope of tangent when that is delta y by delta x, delta y by delta x, and here delta x tends towards 0. At any instant point, there is very some difference of x2 minus x1 is very small. Here is difference of delta x is very small, tends towards 0. At any instant point, this slope delta y by delta x tends towards 0. So we can say slope of tangent that is delta y by delta x tends towards 0. So it is the rate of the curve at delta x tends towards 0. Okay, for examples, if we want to be described a ball towards the earth from some height, okay, then we can say s equal to ut plus half gt square and u equal to 0. In physics you already know s equal to half gt square. Now at any point, at any instant, we want to be find the rate of the velocity. So we can say this difference of any 2 point, timing of any 2 point, let it is t1, it is t2, this delta t going to be towards 0. Delta t tends towards 0. At these conditions, if we take some examples, if we take time from here to here and this is decreasing, then we can find the rate of the velocity, and velocity, then we will find here, that is, you can see we will find the velocity of delta s upon delta t tends towards 0. At these conditions, what the velocity we will find here, okay, delta s upon delta t tends towards 0, that is the rate of velocity at an instant point, and this is also known as tangent of slope of this curve. If we draw the curve of this graph, s equal to half gt square. Okay, so student, this is also described by this letter a differentiation of s with respect to time. Here, differentiation of s with respect to time, it is also known as differential calculus and slope of tangent, and it is also known as differentiation or so now we can find out this value of this velocity with some examples. When putting the value of t1 and t2, we can find the velocity here. Okay, I'm not going to be described more of this, I'm describing some more. Now here is a curve, here is a point A. Okay, let just right side another point where A plus h is another point where h equal to delta x tends towards 0 on the right side. Okay, similarly, if we take the left side at distance h, that is the point A minus h. Now this point is at A, P, B. So A point is F, A minus H, F A minus H, and B is A F A, and C is A plus H, F A plus H. So if we want to find the slope of the tangent, then slope of the tangent for AB, that is y2 minus y1 upon x2 minus x1, f a minus h minus fa upon x2 minus x1, h tends towards 0. Okay, so this is known as the left hand derivative, LHD. It is known as left hand derivative of x equal to a. And similarly, if we take for if we take, it is for AP, and it is now take for AB, PB. Okay, so now for PB we can take the slope y2 minus y1 upon x2 minus x1, h tends towards 0. Okay, so it is known as RHD. So if RHD and LHD may be defined and are equal, so we can say a function fx is differentiable at x equal to a if LHD equal to RHD, LF dash A equal to R f dash b. You can see, we understand from this graph A, P, P, B. If both are equal, slope of both are equal, then what happen? This will be a tangent. Okay, this will be angle it reduced to 180 degree. So if LHD equal to RHD, both slope are equal, then what happen? This angle will be 180 degree. So this will be a tangent. So for tangent, it should be LHD equal to RHD for this point. Understand? If LHD equal not RHD, the function is not differentiable. Okay, student? So using the formula, this formula, we can find out so many functions. Function is differentiable or not differentiable. If it is only if it is not differentiable, then it is not continuous, and if it is differentiable, then it is also continuous at this point, at given a point. So I am going to be tell you about this. So you can note down this theorem with proving if a function is differentiable, at a point it is necessary continuous at that point, but the converse is not true. But the converse is not true. Means if it is differentiable, then it is continuous. Okay, but if it is continuous, we cannot say it is differentiable. Okay, not necessarily true. Okay, so in another way we can say fx is differentiable at x equal to, let's see, indicate that fx is continuous at x equal to c, but the converse is not true. Okay, so student, I am going to be giving a proof for this theorem. Let x, a function fx is differentiable at x equal to c. Let a function fx be differentiable at x equal to c. Then we can say limit x tends towards c, fx minus fc upon x minus c, y2 minus y1 upon x2 minus x1. This is slope. Okay, this way you can learn it, and this will be exist infinitely. This will be exist finitely. Let limit x tends towards c, fx minus fc upon x minus c equal to f dash c. F dash c, dash means here differentiable. Okay, dash means here differentiable at c. So we can say if a function is continuous, what we already proved, RHL equal to LHL equal to FA. In the previous lectures we have already described in the continuous chapter. So in order to prove that fx is continuous at x equal to c, it is sufficient to show that limit fx should be equal to fc. Okay, so this limit should be equal to fc. This is the rule of continuity. So now taking this step, fx x tends towards c, this limit. Now in this we can write this way by adding and subtracting fc plus fc. There is no problem. If we subtract this minus c and add this plus c, that's no problem. Now take in one bracket, and now we can write here fx minus fc plus fc. Okay, now in this bracket we multiplied by x minus c and divide by x minus c. Okay, now we can write here limit x tends towards c, fx minus fc upon x minus c into x minus c, x minus limit x tends towards c plus fc limit x tends towards c. Now it is constant, so limit is fc only. Now what is this? This is f dash differentiation. Okay, so we can write here f dash c. Now putting this here c, we will find c minus c plus limit of this is fc. So f dash c into 0 plus fc. So now we can see if this is exist, then this is equal to fc. So if this is exist, it is true, then it is equal to fc. So we can say fx is continuous. Okay, at x equal to c. So if the function is differentiable, then we can say function is continuous also. But converse is not true. Example, we can take one example here. The function fx equal to mod x is continuous at x equal to 0, but it is not differentiable. At x equal to 0. Okay, so converse is not true. If function is continuous, then it is not differentiable. It may be or may not be, but it is differentiable, then it is continuous. So student, I am going to be solve few questions on this topic. Now let a question is show that fx equal to mod x is not differentiable at x equal to 0. If it is not differentiable, it means LHD equal not RHD. Okay, so LHD at x equal to 0, what is the formula? That is limit x tends towards 0 minus, that is fx minus f0 upon x minus 0. Value of c is 0. Okay, so putting this value 0 here means in this here mod 0. Okay, that way we can find f0, and letting 0 minus h, we put here mod 0. So now we can write f0 minus h minus f0 upon 0 minus h minus 0, h tends towards 0, equal to f minus h minus f0 upon minus h, h tends towards 0. Now taking this value, what is the given our in mod? That is the mod of minus h minus mod 0 upon minus h, h tends toward 0, mod of minus h, but we got it, that is h, and 0 mod is 0 upon minus h, h tends toward 0 minus 1, h tends toward is constant, therefore it is minus 1. Now for RHD, similarly h tends toward 0 plus, we can find f0 plus h minus f0 upon 0 plus h minus 0, so we can write fh minus f0 upon h, h tends toward 0, we can write mod h minus mod 0 upon h, h tends toward 0, we will h minus 0 upon h, so we are getting here 1, that is equal to 1. So we can say LHD equal not RHD. Okay, so function fx is not continuous, so we can say LHD at x equal to 0 equal not RHD at x equal to 0, hence fx is not differentiable at x equal to 0. Okay student, are you understanding the topic? Now do more questions. One more question is there, that show that the function fx where fx equal to x minus 1 or 2x minus 3, and this can be taken if x less than 2, and this can be taken if x greater than equal than 2, is not differentiable at x equal to 2. Okay, so we can take LHD at x equal to 2. So we can say f2 minus h minus f2 upon 2 minus h minus 2, h tends towards 0. Okay. Now it is f2 minus h less than 2. Less than 2 we can take this function. Less than 2 we can take this function. So we can solve here. First f2. 2 minus 1 equal to 1. We will take this function. Okay. Now f2 minus h. 2 minus h minus 1 equal to 1 minus h. Now putting here 1 minus h minus 1, value of this and value of this, what we have solved here, upon here is minus h, that is minus h upon minus h, that is equal to 1, equal to 1. Okay, so we are finding here LHD is 1. Now for RHD at x equal to 2, that is f2 plus h minus f2 upon 2 plus h minus 2. Okay, so we have to find f2 plus h. 2 plus h we greater than is this one. Okay, here f2 will be take this, LHD is this, so f2 is 2 into 2 minus 3 equal to 1. Okay, now f2 plus h for this function, 2 plus h, putting here x into 2 plus minus 3. So what we get here, 4 plus 2h minus 3 equal to 1 plus 2h. So putting here what we get, 1 plus 2h minus 1 upon h, h tends towards 0 equal to 2h upon h equal to 2 equal to 2. So we can say here, since LHD at x equal to 2 equal not, RHD at x equal to 2, hence fx is not differentiable. Okay student, at x equal to 2, right? So this way you have understand some questions regarding LHD and RHD. So student, in the next video we will learn about the differentiation. What is the differentiation? We'll learn about that. Okay, thank you for